Okay जी, second year, hopefully you are well. फर्स्ट ऑफ ऑल स्टे होम स्टे लाइव, अपना बहुत ख्याल रखें इस क्रिटिकल सिचुएशन में। और इससे एफर्ट जो कॉलेज कर रहे हैं आपके लिए ऑनलाइन, उसमें भी पार्टिसिपेट करें। दिस इज़ फॉर यू गाइस, ताकि आपका रिज़ल्ट अच्छा है आपके फ्यूचर के लिए। सो फर्स्ट ऑफ ऑल वी आर गोइंग टू रिवाइज द यूनिट नंबर 19 एटॉमिक स्पेक्ट्रा, lecture number 1. The main topics in this chapter, we are going to touch the main topics which are important for the board as well. First of all, Bohr model of the hydrogen atom. The postulate electron revolve in circular orbits around the nucleus under the influence of Coulomb force. This one is a Coulomb force, F is equal to K square divided by R square, and of attraction between the electrons and the positively charged nucleus. Electron outside the nucleus contain negative charge. Inside the nucleus there is proton which contain positively charged. Positive charge neutron contain no charge. So this was the first postulate कि electron revolve करेगा because of the Coulomb force. And the second postulate is only those orbits, वो ही stationary orbits allow होंगे जिनका angular momentum किसके equal होगा, integral multiple of what, h by 2 pi. H is the Planck's constant, so mathematically we can write that as mvr, which is angular momentum. If the angular momentum is equal to n h divided by 2 pi, then those orbits will be allowed. यानी इलेक्ट्रॉन उन्हीं ऑर्बिट्स में रहेगा, किसी और ऑर्बिट में एग्जिस्ट नहीं कर सकता. इन दिस केस h is the Planck's constant and the value is 6.625 in 10 to the power minus 34 joule per second. So third postulate is electron is stable in stable orbit does not radiate energy. क्योंकि इलेक्ट्रॉन जब तक स्टेबल है, रिवॉल्व कर रहा है इनसाइड इन द ऑर्बिट, तब तक वो एनर्जी रेडिएट नहीं करेगा ना. एनर्जी ऑब्जॉर्ब करके हायर ऑर्बिट में जा सकता है, लेकिन एनर्जी रेडिएट नहीं कर सकता. And the fourth one is energy radiate when the electrons jump from one allowed stationary orbit to another. एक लाउड ऑर्बिट से दूसरे लाउड ऑर्बिट में जब वो जंप करेगा, फिर वो एनर्जी रेडिएट करेगा. अदरवाइज while staying in a single orbit, in a single stationary orbit, it will not radiate any energy. And कितनी एनर्जी वो रेडिएट करेगा, द फॉर्मूला इज गिवन एज एच एफ इज इक्वल टू ई एन माइनस ई पी. ई एन इज ग्रेटर देन ई पी, मीन जो एन ऑर्बिट है उसकी एनर्जी ज़्यादा है और जो पी ऑर्बिट है उसकी एनर्जी कम है. सो रेडियाई ऑफ क्वांटाइज्ड ऑर्बिट, यानी जिस ऑर्बिट में इलेक्ट्रॉन स्टे कर रहे हैं उसका रेडियस कितना होगा. फॉर दैट वी हैव कंसीडर दिस डायग्राम. दिस इज द पॉजिटिवली चार्ज न्यूक्लियस, दिस इज द इलेक्ट्रॉन मूविंग विद वेलोसिटी v having mass m, this is the centripetal force, and the radius is given as r, and the mass of the proton or nucleus is considered as capital M. So centripetal this one is the Coulomb force, and the Coulomb force is given as K E E R N square, or N is the radius, E stands for proton and E stands for electron. We are going to consider only the magnitude, not the charge. So here we got the positive signs for both of them. So F is equal to K square divided by Rn square. Obviously an object is moving in circular path, so it will contain the centripetal force. Due to this centripetal force, it is going to circulate in the move in the circular orbit, and that is given as mv n square or n. These forces, Coulomb force and centripetal force, should be equal for the motion of the electron inside the circle around the nucleus. Putting the value 1 Rn will be cancelled with the other Rn. The remaining fraction will be mvn square is equal to K square divided by R, and this is equation number 1. M is the mass, V is the velocity, K is the constant, Coulomb constant, and E is the charge, R is the radius. Now, according to second postulate of Bohr, mvr is equal to nh divided by 2 pi. Which means that the second postulate, only those orbits are allowed for the electron for which the angular momentum is given as nh divided by 2 pi. So Vn is equal to nh divided by 2 pi. mrn इधर आके divide हो जाएगा. So put this value Vn in this equation. So finally you will get this relation, v nh divided by 2 pi mr n whole square is equal to k square divided by r n. So यहाँ से आर एन सेपरेट करेंगे, दिस विल गिव यू एन स्केयर एच स्केयर डिवाइडेड बाय 4 पाई स्केयर के ई स्केयर एम. This one is the constant, h is the Planck's constant, and its value we have discussed 6.63 in 10 to the power minus 34 joule second. And the remaining are also the constant, pi be constant है, k की value be constant, e be constant, m be constant. So we will get the value 0.053 nanometers. This one is the basic relation for the quantized orbit, radius of the quantized orbit. आपने पहले orbit का radius find करना है, you are going to put 1. For the second orbit you are going to put 2, and up to so on, n की value put करते जाएं. So revise this lecture at home. If you got any question then you can ask in the group. Thank you very much.